What is going on, everybody? This is Anam Shiraz and you are watching MaxcoTec Learning. First of all, apologies for getting back quite late. I've been busy with some of my personal matters, but I'm going to try my best to keep myself consistent this time. So with that, let us get started with our very first video on this new playlist, Snowflake, with the first interesting topic in here, where we are going to look at how we can capture the data change within the Snowflake table, whether it's an insert, delete, or update, and send it over to our Kafka topic. Just to let you know, this tutorial is also available on our website. If you head over to Learning and under Read and Learn, you will see this over here. And also you'll be able to get all the source code for this in our repository. Before we start, one last thing to request is smash that like button if you like our content, and do subscribe if you haven't already. Video outline includes, first of all, we are going to set up our Kafka cluster, of course, and then we are going to install S3 source connector on this Kafka cluster. And the responsibility of this connector will be to listen on our S3 bucket, and as soon as the new file lands, it is going to read them and send them over to a specific Kafka topic. Then we also need to set up Snowflake integration with S3 bucket so that Snowflake has necessary permissions and access to offload the table's data into our S3 bucket. Once that's done, then we are going to move ahead and study briefly about Snowflake Streams, especially the change data capture scenario that captures the deltas of the table whenever there is a insert, delete, or update operation in the table. Once we have set up the streams, then it's time to test Snowflake to Kafka end-to-end. And in the end, finally, we are going to conclude by discussing some of the limitations of this approach, as well as where to and where not to use this. So let's get started. The data flow would look something like this. So we will gonna have a Snowflake in which we are going to set up streams against a given table for which we need to capture the changings, and we will offload these changings into S3 bucket by using Snowflake copy into command. And that's why we do need Snowflake integration that connects with our S3 bucket. And from there onwards, the S3 Kafka source connector, which will be installed in our Kafka cluster, will read these changings from S3 bucket and send it over to Kafka topic. Simple enough. So this is one of the approach to do this, whereas we do have some other approaches. For example, you can try out the Kafka JDBC source connector. Someone has already given a tutorial on this approach. The link will be on the description below. However, the reason I didn't went for this approach is because of the limitation that this JDBC source connector, which is provided by Confluent, does not has a key pair authentication method with Snowflake. The only way this JDBC source Kafka connector authenticates with our Snowflake is by using username and password. So anyway, the second approach would be to use and try out the AWS queuing mechanism to be connected with the Kafka by using SQS source Kafka connector. With any of the approach you are going to follow, you have to keep one thing in mind, that Snowflake does not provide an event-driven approach on notifying the table changings automatically. So this Snowflake stream is actually a query-based change data capture instead of log-based change data capture, which means that these streams are going to capture the change data in the form of a table, which needs to be queried on a fixed interval to check whether we have any changings or not. So people usually add this term streams in this approach, but I do not believe that it's like pure streaming because of this limitation. However, if you can capture and tail the bin logs of the Snowflake, then that could be made kind of an event-driven approach where you can like capture the changings as soon as they are happening and you can like trigger them onto the Kafka topic. We are going to run and set up our Kafka using this Docker image provided by Lenses. So it's a really good for development, and it contains like everything you need to know and have for development and as well as production purpose, including Zookeeper. It has schema registry. It also has a lot of Kafka connectors with it. To use this, I have composed a Docker compose file that looks something like this. So the image would be referring to as lendoop fast data dev, and we call this container as Snowflake Stream Kafka. It will be hosted under this address, and it exposes several ports for different services. So this is for Kafka, and I think this one is for Zookeeper, and it has its own nice looking web UI as well. So we'll look at each of these ports in a bit. To spin this up, we simply say docker compose up. Okay, looks like everything is up, and we can go into this address and access the port. Should be 3030, I guess. There you go. So we are up with a nice looking UI where we can see the Kafka topics, registry schema, and also we can attach several connectors with it. So if you press enter, we are here in the connectors dashboard. We click new. Here search for S3. In the source, as you can see, it has S3 source connector. You also have a sink as well. Since we want to load data from S3 to Kafka, so S3 will be source in this case, so we select S3 source connector. So in here you have to add a bunch of configurations to allow this connector to connect with your S3 bucket. You can get the full documentation of this connector configurations on this page. I will add the link in the description below. So we have to add configurations matching this specs. So as you can see, the Kafka query that it will run to ingest data from the source and send it to Kafka is this: insert into topic name, select all from the bucket name, and then wherever your files are landing. So before finalizing the configurations, let us head over to our AWS account and make sure S3 bucket is there and we have a desired user with credentials with write access. I have created this S3 bucket, MaxcoTec dev, and I head over to IAM users, and for this let us create a new user and call it as Snowflake to S3 to Kafka user, and we say next, create user. We have this user in here, and then we head over to add permissions. I would just go ahead and create an inline policy, switch to JSON, and here you need to provide the list buckets in the given bucket. And then so I think this just requires put and get, but for now I'm just gonna say all actions on objects, and in here I'm gonna mention my bucket name. So this permission should do the job, but you can feel free to strict this further. I think this connector just needs put and get. Go ahead and review policy, name this as S3 read write. Well, I would just mention this with the bucket name. Right, we have user with inline policy attached. Now we head over to security credentials and create an access key. Others, next, create access key. Now we go back to our configuration page and paste the following with the AWS secret key as mentioned in here. Copy, paste, and AWS access key will be this one. Yep, this looks good, although we see a warning saying topics config is unknown, but I think it's not, it's just giving false, because you can see we can like list down the number of topics in which we need to insert these data which we are reading from S3 bucket. So in our case we are saying insert into S3 Kafka ETL, so this would be the name of our Kafka topic. So what goes into this topic is select everything from this bucket and this directory, so everything which is falling under this directory. So we can create a user folder in here called users. So this is referring to the name of our source table. Hopefully this should be all looking good. Yeah, so data will be in the form of JSON, so we will say as store as JSON. Okay, cool. Yeah, that is looking good. So we say create. We can see the logs of this Kafka source connector just to verify that it has successfully established the connection with the source. So for that you can just go in here and click this settings icon in here. So this is green, that means it has successfully connected, but if in case it fails and you need to know what's the reason of it, usually it will display the logs in here in this screen, but you can also tail the logs if you go back to the home screen, and it does provide the list of the log files for the running services. So if you click this, and here you can go to the connect distributed. There you can see the logs, everything's looking good and seems like it has successfully established the connection. So if for some reason the connector is failing, you can always go into the logs and all of the errors will be shown in here. And we go back to our main dashboard and we don't see our topic right now because nothing has been sent into that topic. So our Kafka cluster looks good. We have set it up the S3 source connector as well. So in order to allow Snowflake to land data in our S3 bucket, we have to create a storage integration. So this part may be boring for some of you if you have already configured a storage integration into your existing S3 bucket, but if not, you can just follow along with me and set up this. So the first step, it asks us to create an IAM policy with the following permissions. So let us copy this and head over to policies, create policy, and paste this. We need to change our bucket name. And this prefix will be users. Right, so this looks good. Next, review, and we are going to call this as Snowflake Access. Next, we are going to create an IAM role with the trusted entity as another AWS account. So we go to roles, create a role, another AWS account. So it says in your account ID, enter your own AWS account ID temporarily. Later, you will modify this trusted relationship and grant access to the Snowflake. Okay. Yep. So this is already selected. Select required external ID. Yep. We'll take this. So in external ID, it says just to add this as a dummy for temporary basis. Later, we are going to change this. We are going to attach the policy that we just created with this role. So next, policy, Snowflake Access. Next, we call this role as Snowflake role. Okay, I think from this point onwards, we have to head over to our Snowflake console and create an integration. So let me copy this all and go to Snowflake and create an integration. We call this as AWS demo S3. This is an external stage and the provider is S3. AWS IAM role, we here should be providing the role IAM that we created in this step here. So we can copy this and mention this in here. And then we have to specify like what are the allowed locations in S3 bucket that this integration has access to. So in this case, we are going to say this properties copy. For now, we are not going to add the blocked locations, but you do have an option to do that. We can remove this part. Right, so this all looks good. Let us go ahead and run this. Okay, it did give me an error with insufficient privileges when I was trying to run it with sysadmin role, but it does works with account admin. So we can go with it for now. Okay, so we have our storage integration created. And now what's next is we are going to get the details of this integration. So describe integration and the name of the integration. So the next step is to update the S3 role trust relationship. So first of all, we copy this whole and edit trust policy and we paste it in here. And we replace the Snowflake user ARN with whatever is mentioned in here of our integration description. So in this case, we copy this. And the external ID in this case will be the storage AWS external ID. We copy this from here to here. Okay, looks good. Update policy. So this is how our Snowflake role trust relationship would look like. So let us go ahead and create an external stage, which is, as it says, the reference of the storage integration. So in my case, I'm using account admin role, which is a higher level role. So I may not need to add these grants, but if you're using or have created your own role, then you may need to grant access to the role to create the stage and to use the integration. Let us create this stage. We copy this. AWS demo S3 storage integration, and here we need to provide the S3 bucket path, and the file format, we just create this inline as type JSON, and the compression is none. We say compression equals none, which I am going to explain this why later in this video. So let us go ahead and create this stage. And with that, we are done. So we have storage integration that allows our Snowflake to connect with our S3 bucket. We have a stage which we can use to offload the data from Snowflake to S3 bucket, as well as upload the data from S3 to Snowflake. So now let us jump into our core topic of Snowflake Streams. That is going to load the deltas of the source table into S3 bucket using this stage. So before going into the hands-on demo, let me give you a brief introduction of the Snowflake Streams and how it works. So a stream is a form of a table that you can attach with any source table, and it returns the inserted or deleted rows from that source table since the last time the stream table was accessed. Using streams, you can set up a change data capture scenario where you can only take new or modified rows, sometimes called deltas, into consideration for the remainder of your process. So for example, when loading a dimension, you can only take the new and the updated rows from the source table, and which makes the process more efficient rather than reading the entire table again. So the way how it works is actually by keeping track of an offset, which is a pointer which indicates the point in the time since you last read this stream table. And in terms of the pricing, while it's a query-based CDC, as I mentioned before, but Snowflake Streams actually have some other benefits from the cost perspective. A stream will only fetch the new data when there are changes to the source table, and any logic will consume data only when there is data in the stream and not all the time. So that means that any logic that we implement afterwards will consume credits only when there is data in the stream and will not consume credits when there is none. So without going into any more theory and making you more and more confused, let us go and dive into the DataGrip IDE, which I have connected with my Snowflake, and see the streams in action. Right, so from your Snowflake account, use the desired role, database, and schema. And from that, we are first going to create a small table called users with ID, first name, and last name. And then we are going to create a stream against this table. Create or replace streams, users, change data capture stream on table users. Let us run this first. And then we can actually see whether we have any deltas in these streams or not by typing the command select. Then from the command streams has data, then mention the name of your stream. And this is going to return you Boolean variable true or false. So in this case right now we have false because nothing really has been modified in the source table since we created this stream. So let's move on and insert some rows in this table. Let's add like 3 random users, and now if we run the same command has data, in this case this will say true. So let us see what this data has. For that, you just simply treat this stream as a table. So you say select all from the name of the stream. As you can see, it returns the exact same source table with some additional columns in here. In here, this metadata action indicates the DML operation, whether it's insert or delete recorded, and metadata is update indicates whether the operation was part of an update statement. We only did insert operations, so the actions are all insert and none of them is updated. And this last column, row ID, specifies a unique and immutable ID for the row, which can then be used to track changes to specific rows over time. There are like 3 types of streams that Snowflake offers: standard, append only, and insert only. I'm not going to the details of that for now. So this right now which we are using is the standard one, which tracks all of the DML changings in the source table. Now since we have the deltas captured in this stream, we can now offload these deltas into S3 bucket by using copy into command. So we'll say copy into the name of the stage that we created from this stream table, override equals true. Let us go ahead and run this. Right, so it says insufficient privileges to operate on stage. Of course, because we are using sysadmin, so I'm gonna change this to account admin, because this stage was created using account admin role. Right, so it's saying unsupported feature, unloading of more than one column or non-JSON values. Okay, I think I know what's the cause of this, because the file format of this stage is JSON, and whereas we are trying to copy this stream table in a non-JSON format. So let us go ahead and do something different. So instead of this, what we are going to do is select the items from the stream table in the form of a JSON object by using object construct method. So we say copy into the name of the stage that we created, and then we are also specifically mentioning the full name of the file that will be landing in S3 bucket. And this only works when we say single equals true, and override equals true means that this file will be overridden. And we are mentioning the file format here for this copy into command as exactly the same as we had in the stage, JSON and compression equals none, and this would be user ctc stream. Okay, now let us go ahead and test this out. Cool. Okay, so this just ran successfully. That means the file should have now been landed into our S3 bucket. Let us go ahead and see this. Nice. So we have mydeltas.json. If we try to query this, JSON, okay, nice. As you can see, we have the deltas coming into our S3 bucket. Now, since we have already connected S3 source connector with our Kafka cluster, we should automatically now, so this connector should automatically now receive that file and read the content from it and send it over to our Kafka topic. Before we saw the total topics were 10, and now we can see 11. That means the Snowflake connector automatically created this new topic for us, which looks exciting. That means things are working. So let us go ahead and go under this new topic and see what's happening. S3 Kafka ETL. So it's going to take a while. And yep, as you can see, we have 3 items being sent into this topic, each of the row being added. Okay, cool. Now let us go ahead and see the status of the stream table now. So if we run this command again, to check whether this stream has the data or not, and this time we are going to see false, and that is because of the reason that we have consumed the data from this stream, and now the stream is up to its latest offset. Now let us add another row into this table. We call this as for John plays, I don't know, just a random name. Let us insert that, and now let us check whether the stream has the data or not. This should say true, and let us check out the content of the stream. Nice. So now, as you can see, we are just seeing the deltas. We are not seeing the complete table. So now we have to offload this new deltas into S3 bucket in order to be loaded into the Kafka topic. But you have to keep one thing in mind, that the S3 connector is not going to catch the files with the same name that are being already processed. So my deltas.json file was already processed. Although the content of this deltas table has now been changed, but the S3 source connector is still not going to work. So you have to make sure that this file name is different every time you run this copy into command. So you can like add random UUID in front of this file. But for now, demonstration purpose, we are just going to add something called, I don't know, 123. If I run this, we are going to see another file in this bucket. And now we go to our topics and we refresh. We can see a new feed into this topic, which should be this one, John Blaze with ID 4. Cool. So that means everything is working end to end. So one thing I do want to mention is that, as I mentioned about this S3 source connector, is a bit picky on the source file names in the S3 bucket, that it's not going to process the same file name again, whether or not the deltas are same or not. So for that, you have to make sure that every time you run the copy into command, the destination file name has to be different than the existing one. You can use the UUID string function in Snowflake to do that. The another thing this Snowflake source connector is picky about is that whatever the file format that we are mentioning, so in this case we say type equals JSON, it is only going to pick up those files which are ending with .json. Now if we don't add this compression equals none, and we say like compression is gzip or parquet, in that case what happens is that this copy into command adds .gzip at the end of this file, which is not going to be picked up by this Snowflake S3 source connector. So that was the problem that I faced. So for that reason, I had to mention the file name specifically by saying single equals true, and also I have to mention compression equals none. To conclude, what we have covered so far is we have seen how to capture table deltas using Snowflake Streams. We have seen how we can offload these deltas to S3 bucket, and then from there we read these S3 files and send them over to Kafka topic using S3 Kafka connector. This whole operation can be automated using a Snowflake stored procedure, which can be run on a scheduled basis using Snowflake tasks. In the end, I would like you to keep in mind following points. As I mentioned before, that Streams does not cost credits if there are no deltas captured. So no matter what your pooling interval is for this Snowflake task, you won't be charged anything extra unless and until there are deltas in the table. However, this is not the case in S3 source Kafka connector, because this connector also operates on a pooling mechanism. Because remember, this connector is not using S3 event notifications. So it has to read the following S3 destination on a frequent interval in order to check whether it has new files to read or not. And in case if the size of the S3 bucket is big, then frequent pooling is going to cost us on S3 read operations. If you look at the similar Kafka connector provided by Confluent, they do have this property called S3 pool interval in milliseconds, which is like adjustable on how much we want this connector to read the S3 bucket in order to identify the new changings. But I couldn't find a similar variable in S3 Kafka source connector that we are using, that's provided by Lenses. So by looking at the logs, it seems like they are pulling on quite frequently, I think within seconds, which is not ideal in case if your S3 bucket is big. And because of all of this, remember that this is not at all a streaming solution. It's best for the scenarios where you want to capture the deltas of the tables on a scheduled basis. And I would recommend that it's not ideal if the pool interval is less than an hour. So that is all for this video, and I hope it was informative for you guys. If you have any questions, please leave them down in the comment below, and I will try my best to respond them as soon as I can. And also do let me know that if you want to see more of these Snowflake videos, I am going to bring them up for you guys as well. And lastly, if you're new to this channel, don't forget to subscribe. This is going to keep us motivated to bring such useful stuff to you guys in the future. So I will see you guys in the next video. Take care. Bye.